Hey, welcome back. This is part two of an unintentionally two-part MasterCAM fourth axis training video. This is actually take two because the first take didn't record. Darn it. So just as a recap, this is intended as an introduction video for those who are already familiar with MasterCAM, but specifically it'll be for fourth axis camming. It's going to be a lot like 3D surfacing. So it'd be helpful if you've already become familiar with 3D surfacing. If not, it's not critical. All right, let's jump back in and we're gonna pass over to MasterCAM. All right, awesome. So here we go. I have pulled up the same part that we were using. And the only thing that we have left to cover is actual rotary toolpaths. We've already covered wrapping 2D toolpaths and with axis substitution, and then indexing. But this is the third one that we use all the time. I've already pulled in the toolpath, but I'll just show you how to pull it up again. You'll bring in your machine and everything, part, data, and whatnot, and then we come to toolpaths, drop down on multi-axis, and click on rotary. Oh, I've got to bring this over. There we go. So the rotary toolpath is one of the multi-axis toolpaths. It's currently, at the time of recording this video, the only multi-axis toolpath that we have access to on our license. But it's also the only one that we could feasibly use. So I'm going to close this one and open up the one that I've already created. Okay, so we're just going to step through some different stuff and hopefully cover the basics. We're going to be using a ball end mill. Like most surfacing operations, you don't want to be using a square unless you're roughing. Even then, I'd probably use a bull nose. We're going to ignore speeds and feeds for right now. So the first biggest thing to note with this toolpath is, like a surfacing operation, you just select drive surfaces. There we go. I unselected it so we can show you. You just select the one you want to do. We're going to surface this funny deflated airbag. End selection, and that shows us our drive surface. Next, you pick the style of cut. If you watch the picture over here on the right, an axial cut will cut straight lines along the fourth axis, or while a rotary will spin the fourth axis and cut on top of it. Picture does a better job than my words, so just check that out. Compensation, type, and direction. These are things you're all familiar with. We're going to keep them like they are right now for climbing. This box is going to be important though. They have added a feature in the tree over here called roughing since I became familiar with fourth axis toolpaths. So my guess is there's now a way to do roughing steps like depth cuts. But originally they didn't have this, so the way that we would rough a part is to add stock on the drive surface, and you would have to create a new toolpath for every time you want to do a depth cut. Because if you go straight from the outside uncut stock down to the surface of your part, you're probably going to break your tool. I would encourage you to look into this roughing option, see if we can figure that out. But for now, a workaround, if needed, is to just copy this toolpath a bunch of times and have different amounts of stock on your drive surface until you get down to depth. All right, so continuing on, this tool axis control is a pretty important menu. Depending on what you select up here, be it rotary or axial cut. Let's try an axial cut first. It will allow you to select different options in here. So in the axial cut options, the picture again does an even better job than my words will, but your max increment angle is kind of like your step over in a rotary setting. So that will dictate your finish resolution. Your start angle is at what angle you want to start cutting, and then the sweep angle is how much from that start angle you'd like to surface of the part. So if you only want to do half the part, you would put in 180 here. Let's see, I've never ever changed this, but if we do move the fourth axis in the VF4 to something that is not X, you could change that here, but for now, keep it on X. Let's go back to a rotary cut. All right, so now it's allowing us to play with these options. These ones are pretty important because you can play with them to cut overhanging objects on your part. I drew some rough drawings here so that we can talk about what this means. But right here, the first option is use center point. You can uncheck that or check that. The picture does a fantastic job of showing if you have used center point, it will keep the tool over the center of the part the entire cut, where you can uncheck that and let the tool move off from center line of the part while it's cutting. Seems trivial at first, but when you move into overhangs, this is actually really important. So, axis dampening, I have never used this one, but from my understanding, it just adds extra surface on the part, kind of like your leave stock on drive surfaces will do. You'll want to check me on that though, because I haven't played with it. Maximum step, this is your step over again. This is an axial dimension, so this would be 15th thou step over. Lead lag though, this one is also very important, much like the use center point. Between the use of turning off use center point and changing your lead lag angle, you can cut overhangs. So we're going to come back to the video and these rough drawings to try and explain what I'm talking about. Oh, right. So right here, this would be turning off your use center point. So normally it'd be constrained over the part. You could have it come over and cut down. Not super helpful. We've got this funny overhang feature. It still couldn't get into the corner there. So if you turn on lead lag, it'll allow you to angle the tool and come in and cut on that overhanging edge. It makes a little more sense if I rotate the part. You can now see that the tool is off center line, but it's also at an angle relative to this center line. This one is a little hard to tell because I drew it almost vertical. But if I had a really steep overhang, you would have to angle that tool even more to get into it. So that is where lead lag and your use center point are going to be most helpful, is to try and get into overhangs like that. The biggest thing that I run into with this is that it only works for rotary cuts, not axial cuts. Let's go back to MasterCAM. Okay. So if you're doing an axial cut, you don't have these options. Notice right here, these options are turned off. That doesn't seem like a huge problem, but there is one more caveat that I have to throw out there. Because of the way that MasterCAM is posting for our Haas machine, we can only spool the fourth axis so many times before it errors out. So when you rotate the fourth axis one full revolution, it's gone 360 degrees. If you go one more time, it doesn't reset to 0 and go another 360. It keeps counting and moves to 720. This is an issue because the bit space in the computer at the Haas machine only can count so many times before it maxes out your bit count, and it can't keep counting. You won't know this until you run your program or you run a render for your program and it throws an error. There's nothing in the simulation on MasterCAM end that will tell you, hey, or in the machine definition that will say, our machine can't spool that many times. And I think it's somewhere around 1240 degrees, which isn't that many revolutions. You'll have to check me on that though. So a warning for rotary cuts. They're super helpful, but sometimes we have to be careful with how many times we spool, or our fourth axis won't be able to do it. We'd love to get a post update from Haas, but we're still working with them on that. All right. So we've covered tool axis control, cut patterns. We've talked about the most important things. You're familiar with the stuff down here at the bottom if you've been doing anything with 2D CAM. Climb conventional, one way, and zigzag. Helpful. As a note, zigzag is a way to overcome that spooling problem that I talked about, because it will spool and then spool back, and you never spool over the number that you need. All right, let's see, collision control. Okay, this one is helpful. I don't use it very frequently, but I have selected here 2 check surfaces. I selected the surfaces just outside the part I want to cut. Oh, let's draw another drawing to make this make a little more sense. In this case, it's not a huge problem that we have check surfaces on, but in the case I'm drawing for you, it would be an issue. So let me explain in MasterCAM how it works, and then I'll show you the other example. So I have these selected. I'm going to hit in selection and keep those selected. And you can do stock to leave. This isn't a stock to leave off the drive surface like I've shown you already. I'm going to put in 0.375 and then show you what it looks like when I re-render this toolpath. So we're going to re-render. You'll see it plots some boundaries around the ends of those check surfaces, and then it plots the drive surface. And the portion that they don't intersect, it will allow you to cut. And if your drive surface is somewhere inside of that avoidance region per se, from the check boundary, it won't cut there. So you'll see that 0.375 inches over, it stopped cutting on our drive surface. And if we zoom in a little bit and take a look at this, you can see that there's a couple passes that actually don't go down to the surface of the part. That's because if I drew a line from this edge of our check surface and then made a big bubble around it, this bottom surface interferes with that check surface, so it won't cut in there. It'll only cut outside of that 0.375 radius from this surface, and respectively this surface as well. So in this case, kind of seems a little pointless. We definitely want it to be 0 in order to get the whole part. But if we jump back over to the camera and look at this drawing, if we were surfacing this part in here, and I'm going to draw on the tool so you can see. Alrighty, so there's our end mill. It's cutting. You wouldn't want to actually take the center of this all the way to this point, because if you did that, then you would be cutting into this wall, and perhaps this shoulder is important for your part design, and so you don't want to do that. So you'd select this surface right here as your check surface, and then say avoid it by a radius of my tool, and then it will only take your tool to here as opposed to interfering with the shoulder. And you might want to do a radius plus a little bit of clearance. A few thou would be enough. All right, jumping back. Okay, let's refresh this toolpath. Plotted our check surface. Now it's plotting our drive surface. Boom. Okay, so there's our toolpath. Seems to be working out. We'll keep going. The rest is quite simple. Clearance, all of this is based off the surface of your drive surface. So 0.5, 0.1, 0.01, sure, those are all just fine. You can turn clearance off sometimes based off your application, but it's always safe to leave it on. Anything else we need to cover? Again, this roughing may be very helpful. I just haven't had time to explore it. It may be a way to actually do depth cuts as opposed to cutting straight to your drive surface, and avoid that annoying workaround that we've been doing to do depth cuts. Filter, I've never had to mess with this. And then these settings down here you'd be familiar with if you're familiar with 2D Cam, so I won't cover those. But that's that. That pretty much covers rotary toolpaths. Let's see if there's any questions from the peanut gallery. Did I miss anything, guys? Any questions that we covered in our actual class that I didn't cover this time?
Can't think of any because the problem is I don't have that question anymore. It's just knowledge.
True. Okay, I think we did cover everything. Check over these notes real quick. One last note. If you're wondering, the planes, you'll notice I still have top selected. We had to do some funny stuff with planes for some of our fourth axis work, but this fourth axis work, I'll just uses the original plane that we put in for our datum on the end of the fourth axis through the center. So you don't have to do anything funny with planes, which is nice. It'll take care of all that for you, obviously, with this rotary toolpath. So thanks for joining us, guys. Let's hit this, come back here, and look forward to more training videos next time. Have a good one.